All right, we're going to fly from Visalia Airport to Johnston Airport. Johnston Airport is right on the edge of the city, the great city of Mendota. And the last time we were here, we were measuring the true course, and then we calculated the magnetic course to get from Visalia and go northeast, that is up and to the left, to go northeast to Mendota Airport. So what I'd like you to do is try that again, is get that round compass rose lined up and centered, and then put the edge, one edge on the Visalia Airport like shown in the chart up there or on the screen. Get one edge of the straight line on Visalia, the other edge on top of the airport, and then you have to slide the whole plotter up and down to get that little tiny round hole in the center of the plotter, so it is on a line of longitude. Not to Madera, to Mendota. Johnston Airport, Mike 900. Mike 900 is the three-letter identifier. We're going to go from Visalia to Mike 900. Question? No, if I didn't have my ForeFlight iPad app and I was doing this mechanically, I would probably do it the day before, but it doesn't really matter that much. You know, just for fun, somebody yesterday measured distance. Can anybody measure again? How many nautical miles? 55? Okay, 55 nautical miles, not statute miles. Watch out, because the other side of the plotter is in statute. Okay, so 55 nautical miles. So if our aircraft went 110 nautical miles per hour, and we took off and flew straight, and we flew 110 nautical miles an hour the entire time and went straight there, how many minutes or how many hours would it take to get there? 26 minutes? Can you be more exact? If it's exactly 55 nautical miles and we're going exactly 110 nautical miles the entire 110 knots, 110 nautical miles an hour, 30 what? 30 hours? Oh, no, 30 minutes. Yeah, 30 minutes. So exactly 30 minutes. Now, let's be careful, because are we going to take off and initially fly at 110 nautical miles an hour? Not even if we were in an airplane that could cruise at 110 nautical miles. We're going to climb at our best, if we had our obstacles, we'll climb at our best obstacle clearance altitude, X. But what we've been practicing in the simulator is to fly our best rate of climb, which will get us to altitude faster, and that's VY, and that number for a Tomahawk is 70 knots, indicated airspeed. So, and yesterday, what altitude did we decide we were going to fly at? 3,000, but a little higher than 2,000, so we could stay about 2,000 feet above. So I think what we'll do is we're going to climb to 2,300 feet, just for fun. So if you got a piece of scratch paper, I didn't bring any paper with me, but surely you brought some scratch paper. Is anybody? This is where you say, "Yes, Mr. Johnson, I brought scratch paper, and please stop calling me Shirley." Guys are picking up on this Shirley stuff the way I had hoped. So I'm going to have to stop. I'm going to have to start taking off class participation points for failure for you to not ask me to stop calling you Shirley. So a little piece of scratch paper would be great. So we're going to climb to 2,300 feet. All right. Now, in reality, it's going to take us a little longer than 30 minutes to get there because, one, we're going to climb at less than 110 knots, and I bet you a Tomahawk doesn't cruise at 110 knots. Yeah, I bet it cruises a lot closer to 90 knots. So does anybody, so 90 knots is 1.5 miles per minute. Now, if we climb at 70 knots, and let's just say for fun, we climb at 500 feet per minute, how long will it take for us to get 2,000 feet above the ground? I know this is tough math, Jonathan. I know the math, being a pilot, bothers you. So I'm going to make you tell me, Jonathan. If we climb at 500 feet per minute in our Tomahawk, and we're climbing to 2,000 feet above the ground, How many minutes will it take for us to get to 2,000 feet above the ground, AGL? Which is about 2,300. 500 feet for every, well, which is it? 4 minutes is correct. Yeah, 4 minutes times 500 is 2,000. So 4 minutes times, I did down like this. 2,000 feet, I'm going to climb. And I do 5,000 feet, 500 feet for every minute. So the first 500 feet, 500 goes into 2,000 4 times. So it's going to take 4 minutes. So it's going to impact how fast it takes us to get there. And we haven't had time yet in class to get to all the intricacies of flight planning. In real life, we'd be flight planning based on that 70 knots. And it'll take us 4 minutes. And how far would we go? Is 70 knots pretty close to 60 knots? Yeah, it's within 12 or 13%. Okay, what if we had a little tiny bit of a headwind? What would our speed across the ground be? Pretty close to 60. All right, so if we're doing 60 knots across the ground, how far do we travel in 1 minute? 60 miles an hour, 60 nautical miles per hour. We'll do 60 nautical miles in 60 minutes. So 1 minute we'll travel. Now I want Jonathan to do this because he has had trouble with math. He's worried about pilot math. So since he's more worried about it, then he needs to practice. So Jonathan, we're doing 60 nautical miles for every 60 minutes. So if we travel 1 minute, how far in distance will we go in that minute? 1 nautical mile. So if we're climbing for 4 minutes, about how many miles will we have climbed? I mean, how many miles will we have covered if there's no wind? Say that again? No, we're going to fly straight through it and see if we can hit some F-18s. So 60 knots equals 60 nautical miles per hour. It also equals 1 nautical mile per minute. So how far will we travel if we go for 4 minutes? Yeah, 4 nautical miles. So we're going to take off out of Visalia, and we're going to go 4 nautical miles, and that's going to take us about 4 minutes. Okay, so how far was this trip? 55 nautical miles? All right, so we're going to travel about 4, so we're going to have 51 nautical miles left. But we're not going to be able to, we're not going to do 110 knots, we're not going to do 101 knots. Let's say we're going to do 90 knots. So 90 knots, I want Jonathan to do this because he has a hard time with math, equals how many miles, nautical miles per hour? It's a tough one. 60 knots equals 60 nautical miles per hour, so 90 knots is equal to how many nautical miles per hour? 90 nautical miles. So if we're going 90 knots, how many nautical miles per minute? We're going 50% faster than we were at 60. So for the same amount of time, our distance will be 50% greater. What's 50% greater than 1? 1.5. So at 90 knots, we'll do 1.5 nautical miles per minute. So if we wanted to know how many minutes to travel the rest of that 50 nautical miles, 51 nautical miles divided by 1.5 nautical miles per minute. So 1.5 goes into 45 15 times, 15 minutes to get 45, and that leaves 6 miles left. How many times does 1.5 go into 60? 15 goes into 60 exactly 4 times. So 1.5 goes into 6 4 times. So it's going to take 19 minutes at 90 knots, which is the same as a nautical mile and a half per minute, to go the remaining 51. So this is going to be 19. We could have taken a calculator and said 51 divided by 1.5 equals, and we'd have gotten 19 minutes. Don't worry, I'm going to show you a way that's more fun than this. But I'm just trying to harass Jonathan because I don't like him that much. So the rest of this distance right here is 51 nautical miles, and that's going to be 19 minutes. So 19 plus 4 equals 23 minutes. Now that's if we took off straight out of Visalia and we did not fly a traffic pattern. What if we took off from Visalia and we took off going, whoops, and we took off going south, and then we had to turn and make left turns and then start up. That would give us an extra minute and another half a minute and another minute there. So that could take us 2 or 3 minutes extra than that. Does that make sense? So if I took off and I had to turn around and go back up, I'd probably add 2 or 3 minutes to the flight. But for purposes of this exercise we're going to do today, we're going to say, and it looks like this last thing got erased a second, that's 19 minutes. So 19 plus 4 equals 23 minutes. Now, the last time we did this, we measured 330 true course. Is there anybody who didn't come up with that yesterday? And then east is least and west is best, so we took 330 and we subtracted our 13 degrees east variation. And we got 317 degrees magnetic course. So what that means is a straight line from Visalia all the way to, we'll call it Mike 90, the magnetic course is 317 degrees magnetic course going there. If there was no wind to blow us to the left or to the right, and the compass was perfectly accurate, we could take off out of Visalia and fly 317 on our compass for 23 minutes. And then we could then look out the window, and right below us, or really close to right below us, would be Mendota Airport. That is how you dead reckon. Dead reckoning is literally just flying a particular heading at a certain speed for a certain time, and you will therefore have traveled a certain distance. So we know what the direction is. The direction here is 310 degrees mag course. We know we're going to fly 60 for 4 minutes, and then we're going to fly 90 knots for the rest of the time. We know the distance is going to be we're going to travel 4 minutes at 60 knots, and then we're going to travel 51 minutes, equals 55 total. And we know what the time is. The time is going to be 4 minutes for the climb and 19 minutes for the cruise, is 23 minutes. So time is going to be 23 minutes. As long as there's no wind, this will work out really well. So I haven't looked to see what's programmed into the computer for wind, so that'll be kind of interesting. But on your piece of scratch paper, these are the two numbers I want you to write down. I want you to write down 23 minutes and a magnetic course of 310. And we're going to try to dead reckon from Visalia Airport. And if it puts us down at the wrong side of the runway, when we tell it to go to Visalia, we're actually going to taxi to the far end of the runway. We're going to pretend it's a private airport, and we're just going to taxi down to the other runway so we can take off going towards Mendota. So we're going to take off. So that's dead right. So we're going to look at this more and more, and this is going to feel a lot more comfortable. And I know probably about half of this is kind of, what did he do? But all we did was look at speed versus time versus distance, which is just a division problem. I mean, let's think about it like this. Miles per hour is the same as miles, divided by hours. So that's all we did. How many miles do you travel in an hour? 90 nautical miles per hour equals 90 knots. All right, so there's some dead reckoning. Don't go away yet. Oh, why did it all stay there? going to erase it all. If it'll let me, it won't let me. Maybe it let me. Pilotage, on the other hand, is a different way to navigate, but you're going to do pilotage and dead reckoning at the same time. So I'm going to spend just a few minutes on pilotage. Hey, look, it sort of got me there. All right, and I'm going to reverse this. Dun, dun, dun. So it's possible here in a little bit it's going to go online and it's going to look, if I give it a time. See, today's the 17th, right? 3:45, that looks pretty good. Okay. Let's see if it'll go online and give me some numbers. And just for fun, hey, it says it's 54 nautical miles. I'm pretty happy. So if I was going to look at landmarks can either be man-made or can be non-man-made. In a flat central valley of California, unless there's any rivers, there's not going to be much in the way of non-man-made. The best thing I'm looking at right now is this canal right here. And you know what? It looks, if it's a canal, it's man-made. So I think cities are man-made and roads are man-made and railroads are man-made. So if you look on your chart, if we take off out of Visalia, we're going to be able to see this freeway right away. The airport, you don't know it yet, but the airport is right next to the freeway. Literally, well, maybe you do know it. But the airport is right next to the freeway and the railway. If we take off, we're going to have to turn left a little tiny bit, and you're going to notice we ought to be able to see this turn in the railroad off out of our right window. And if we keep going, we may or may not be able to actually see that VOR. I know what they look like, so it's easy for me to figure out what they look like. But you'll notice here's this town called Layton, and it looks like we've got the intersection of 3 railroads and a little tiny town. The problem is this is a little tiny town. But if I was to, whoops, well, what did I just do? All right, if I go back down there. So this says, let's see if it'll let me move it. There we go. Right next to Layton. All right. It says it's 16 nautical miles. If I used that if I didn't worry about that 60 nautical miles an hour for the first minutes, and I just said 16 nautical miles, that's about 1/4 of an hour. What's 1/4 of 90 knots? Half of 90 is 45. Half of 45 is, what's that? 22.5. So I'm going to go about 22.5 in 15 minutes. Wow, I'll pass this before I get to 15 minutes. The other way I could do it is say 90 nautical miles an hour divided by 16. 16 is really close to 15. 15 goes into 90 6 times. What's 1/6 of an hour? 10 minutes. So on your cheat sheet, say Layton at 10 minutes. So we're going to look for Layton. Now, we're going to go slow that first 4 minutes. So it'll probably be more like 11 minutes to Layton. So let's write 11 minutes to Layton. I don't know if the terrain, the railroad tracks are going to show up and whether Layton is going to show up. What I do think is going to be fun is whether or not we're going to be able to pick up this railroad just before we get to Johnston Airport. And this, whatever this Mendota State Wildlife Area, it is not a federal aviation regulation, but when you see the wildlife areas like this, the request of the federal government, the Department of Agriculture, is that you not fly lower than 2,000 feet AGL over it. So I think what we ought to do is aim for this intersection and when we're getting close and we see that railroad, these railroad tracks, let's go slightly right and get to it, and let's go a little bit farther and stay out of it. Because by the time we get there, we're going to need to be descending. So this is what I would do in ForeFlight. I would just put it like that. And then it would just drive me straight to those places. But it looks like I'd be able to see Kerman. Let's see, based on tick marks, this distance from my course to Kerman looks like, let's see, 1, 2, 3, 4, 5. This looks like about 5 or 6 miles to Kerman. So I might be able to look right out my right window and see Kerman. And you'll also notice that I've got these two towers right out in front of me. We may or may not be able to see it. We might also be able to see this canal. And you notice we're only going to be a mile or two away from the canal. So unfortunately, since there's no big giant landmarks along the way, Layton, it'll be interesting to see if it's in the simulator. But the next thing might be this canal right here. So just for fun, we'll hit that and hit details, and we'll add it to the route. And that's 10 more miles to this canal. You know what? I'd be pretty happy if we took off and just did dead reckoning until we saw Kerman or saw Johnston Airport. So this is what I wanted. This is what I want to do. I finally figured it out. You'll notice that on those little tiny right-hand screens in the bottom right-hand corner, you can call up that map and it'll show you where the airports are. Let's call that up. But let's fly that heading on the compass and on that directional gyro, that heading indicator, let's fly